Hello everyone. So, today's the day. We are going to prove the triangle inequality theorem. It's one of the most important theorems in math. Even though it's a relatively simple concept, it's used in so many fields. I mean, there's a version of it in basically every college math textbook I have. So, let's get started on it. Prove that in any triangle, the sum of the two sides is greater than the third side. This idea is called triangle inequality. So, let's start with the case of an acute triangle. So, let's draw our triangle. And that'll be fine. Whatever. Alright. So we're going to start with some triangle, and we are going to label that triangle. We're going to call it ABC. And I want to prove that the sum of the two sides is greater than the third side. So how can we do this? Well, right triangles are always a super useful tool, so let's create one by dropping the altitude, and I'll label this point D. So now we have two right triangles, and something we proved about 2 lessons ago was that the hypotenuse is the largest side, so therefore we can conclude that AB is greater than BD. Notice I'm not going to compare it with the side AD, since that's not a part of our original triangle. I want to compare AB, which is the hypotenuse of ABD, to one of the other sides, BD, which is a part of the original triangle. And similarly, the triangle ADC, AC is the hypotenuse, so we know that AC is strictly greater than DC. And if we add these two inequalities together, we get the following, that AB plus AC is strictly greater than BD plus DC. And if we simplify this, well, what is this? That simplifies to just BC. So BC is less than AB plus AC. So that is the basic gist for an acute triangle. We have proven that the sum of the sides AB and AC is greater than the third side BC. Now, we could do this over and over again, but it's the same process each time for the other 3 sides. If we were to drop the altitude from, let's say, B, it would be somewhere around there. And then we would just repeat the process, like we could call this point E or whatever. And eventually we would get another inequality. So the other inequalities we would end up getting through this same method would be that AB plus AC is strictly greater than, well, no. AB plus BC is strictly greater than AC. In addition to that, we would also have that BC plus AC is strictly greater than AB. Those are the 2 additional inequalities that we would find, and thus completing the proof. It's the same process I did to find the first inequality, just different altitudes. So this is demonstrating that no matter which 2 sides I add up, it is always greater than the third side. So now let's look at the case of an obtuse triangle. And we'll label that ABC. Now, it turns out the same logic to prove an obtuse triangle's inequality theorem is the same as a right triangle. So I'm not going to prove the case with the right triangle because you should be able to figure it out on your own with the same logic I'm going to show you here. So what is a simple case I can work with? Well, something I know right off the bat is that the side opposite to the obtuse angle is the largest side. So I know automatically AC is the largest side. Therefore, since we have that AC is greater than BC, it must be that AC plus AB is also greater than BC. That has to be true since AC alone is greater than BC, and if you're adding it with another positive value, then it has to be even greater. Another thing we know is that AC is greater than AB. So we know for sure that AC plus BC is greater than AB. So that's the second theorem. Now or second inequality, I should say. Now I just need to find the third one. And it turns out we're going to use this similar technique. We're going to drop an altitude from B to create two right triangles. So, and we're going to look at the hypotenuses, or hypoteni, I guess, of those right triangles. We'll call this point E. So, I know that the largest side has to be a hypotenuse, and since AB is a hypotenuse, we have that AB is strictly greater than AE. Another thing I can figure out is since BC is the hypotenuse of BEC, we have that BC is strictly greater than EC. And if I add these two inequalities together, we get the following, that AB plus BC is strictly greater than AE plus EC. So we have that AB plus BC is strictly greater than, well, AE plus EC is AC. And that is the last inequality we need to prove that each side of an obtuse triangle, if we take two sides, it must be strictly greater than the third. Okay, so in the next part of this lesson, we'll demonstrate a kind of unique case of the triangle inequality theorem.